Hi and welcome again to the channel. A very big welcome indeed. Today in this video we want to look at how to convert a complex number from the standard form or the rectangular form z is equal to a plus ib into the polar form r brackets cos of theta plus I sine of theta. This is certainly not a complicated exercise, and it's a very short video. But let's start off by writing our z here. Is z is equal to a plus ib. Now, we know that we can plot a complex number on the Argand diagram. Now, here is our Argand diagram. I'll draw it here. There it is. And of course, this is our real axis, and this is our imaginary axis represented by y. And of course, this is the origin. When you are drawing diagrams like this, it's very important to label your axis properly, show which one is the y-axis and which one is the x-axis. The tendency is to, make the assumption that, everybody knows this is the x-axis. No, they don't. All right, now, we can say that our complex number z, let's plot it here. A units along the real axis and B units along the imaginary axis. So this would be the point representing z, which is the point A, B on the Argand diagram. Now, we can join this point here to the origin. Like, oh, that's not a straight line, is it? Let's try and make it as straight as we can. Okay, so here is our point there. That's our point there, the line there. The magnitude of this line, let's call it r. Let's say it has got magnitude r, which of course we know it's magnitude of z. I drop a perpendicular here onto the x-axis. Once I've done that, this is a right angle. Supposing now, in my right angle, let us suppose that this angle here is theta. Okay? Right? We know, of course, given the right angle triangle as it is, this distance here is equal to A. This distance here is equal to B. Okay? Now, given this right-angled triangle, we know that B over R is equal to sine of theta. So B over R is equal to sine of theta. Therefore, what is B? B, this implies B is equal to R sine of theta. I've taken R to that side. Similarly, A over R is equal to cosine of theta. So A over R is equal to cosine of theta. And what does that mean? It implies that A is equal to R cos of theta. Now, I now have got these two equations representing A and B. Now my Z is equal to A plus IB. So now instead of A, I can write this. Instead of B, I can write that. So my Z now is equal to R cos of theta for A plus I multiplied by R sine of theta. I can take my R out and I have this is equal to R bracket cosine of theta plus I sine of theta. Okay, now we have obtained the polar form of our complex number. This is called the polar form. This is called the rectangular form. So it's possible always to move from the rectangular form to the polar form and vice versa. Given this, you can get to this. Given this, you can get to that using these two relationships here. B is equal to r sine of theta. A is equal to r cos of theta. Let's take a simple and straightforward example before we leave. Now, let us suppose now that our z is equal to, let's say it's 1 plus I. Okay, let's write it like that. So this is in rectangular form. I want to get it to this form. First of all, I need r, which is the modulus of the complex number. So I will have z, the modulus of z, is equal to square root of 1 plus 1, which is 1 squared plus 1 squared, which is equal to the root of 2. So modulus of z is equal to root of 2. What about argument of z? We know that arg z is equal to arctan 1 over 1, which of course is pi over 4. So arg z is pi over 4. Let me clear this space so I can write my z in polar form a little bit more clearly. Okay, so we have calculated our modulus of z, which is r, it's root of 2, arg z, which is pi over 4, and this is theta here. Theta is the argument of z. So we can write it nicely in polar form as r is root of 2, so it's root of 2 brackets cos of pi over 4 plus I there, sine of pi over 4. This is now z in polar form. What would have happened if we had been given z in this form and we were being asked to convert it to that form? Well, we were going to use those two equations again. First of all, given my diagram there, I know that B is equal to r sine of theta, and A is equal to r cos of theta, or cos of theta. Right, but what is cos of theta? Cos of theta is equal to, theta is equal to pi over 4. So B is equal to, r is root of 2, so it's root of 2 multiplied by, what is sine of theta? What is sine of pi over 4? It is root of 2 over 2. Okay, so that gives you root of 2 times root of 2, which is 2 divided by 2, it's equal to 1. Okay, what about, we have calculated B. What about A? A would be equal to root of 2 r there, multiplied by, what is sine of theta? Sine of pi over 4 is root of 2 over 2, which is that, and again it gives us a 1. So therefore z is equal to 1 for A, and B is 1 as well, so it's just I multiplied by 1, which is that. So we can move back and forth between the rectangular form and the polar form. In our next video, we are going to deal with what is called de Moivre's theorem. I hope I pronounced the name right. It's a French name. but it's de Moivre's theorem, which uses this idea, and we can then proceed from there to the exponential form of a complex number. Till then, take care.